In this presentation, we are going to look at Markov chains, and in particular what we're going to look at are a set of transition matrices. So I have essentially what we're going to do in each case is each of the following cases, for each of the following matrices, explain whether or not it is a valid transition matrix. Okay, so this is going to be short and sweet. So in the first instance, is it a valid transition matrix? Well, one thing we look out for is the fact that it should be a square matrix, which is to say n by n. That is actually valid in this case, okay? Not in this case down here. So we'll sort of do A and B together, okay? So over here, straight away, we have no, okay? This is not a valid matrix here, B. I'm sort of jumping in down to B straight away. So it's essentially based on this criteria. First off, it meets that criteria, but that's not the only criteria. For B, it doesn't meet that criteria, and that alone is enough to invalidate it. So in this case, for B, it's no. A second thing is that the row sums should add up to 1, okay? And straight away, we have a 0 there and a 1 there, okay? Now, these should all equal to 1. All the row sums should add up to 1, should be equal to 1. So in this case, that is a no there, because the row totals do not add up to 1 in that particular case. Despite the fact that this is already disqualified as a valid transition matrix, let's just check that for this matrix here, just in case it actually does meet that particular criteria. That does add up to 1. Okay, and that also adds up to 1. Okay, now it does meet that criteria. It still fails the first one, but it actually does meet the second one, that all of the row totals add up to 1. So let's move on. So first off, we have an n by n matrix here, 3 by 3. So far so good. Let's check out all the row totals. 0, 0.5, and 0.5, 1, 0.2, 0, 0.8, 0.4, 0.6, 1. And that works out fine in both cases. Okay, so in this case, we're going with a yes. It is a valid transition matrix. Now, here's the thing. All of these are plausible probability values. Okay? They're all, and the range of values should be between 0 and 1. Okay, so essentially what you're going to sort of see here straight away, and I'm just sort of flagging it in advance, that we already have an invalid probability value there. We have a negative number, and immediately this is going to be a no. Okay, because it has to be between 0 and 1. It is a 3 by 3 matrix. Okay, so it does meet that criteria. And just disregarding that, that doesn't add up to 1, and it also has a negative value there. So for two reasons, that particular row is no good. The other ones actually do add up to 1. Okay, so for two different reasons, D is not a valid matrix. It has a negative value where there should be a valid probability value, and also the row totals don't add up to 1. So that's a no there. So overall, we only have one valid matrix here, and that is C, the third one. Okay, so we'll leave it there.